number 6 from the mixed review handout, it says a projectile is shot from the edge of a cliff 125 meters above the ground level with an initial speed of 65 meters per second at an angle of 37. So the first thing you have to do is you have to draw the picture. So again, this is where motion begins. Here's my initial velocity, which is 65, and it's going to go like this. Okay? So this is important because remember, first of all, this is my final velocity, which is at an angle. So they tell me that this is 125. Okay? So the first thing we're going to do is we're going to write our x and y given. Okay? So AX is 0. G is equal to negative 9.8 meters per second squared. Now, whenever I'm given an initial velocity like this at an angle, this is 37 degrees, the first thing I'm always going to do and put in my given is I'm going to take that V naught and I'm going to break it up into its horizontal and vertical components. So this is V naught X and this is V naught Y. This angle here is 37 degrees. So V naught X is equal to V naught cosine of theta. So V naught X is equal to 65 cosine of 37. And when we do that on our calculator, it comes out to be 51.9. V naught Y is equal to V naught sine of theta. So V naught Y is equal to 65 sine of 37. So V naught Y comes out to be 39.1. So I'm going to write this in my given. So V naught X is equal to 51.9. And V naught Y is equal to 39.1. Now, they also tell us that Y naught is equal to negative 125 meters. Where do I start? Well, part A says determine the time taken. So when I use the equation Y is equal to Y naught plus V naught YT plus 1/2 GT squared, I have 0 is equal to negative 125 meters plus 39.1 t plus 1/2 negative 9.8 t squared. So I'm going to have to use the quadratic equation. So when I use the quadratic equation, I'm going to end up with 125 is equal to 39.1 t minus 4.9 t squared. So the positive value of t comes out to be 10.4 seconds. For part B, it says determine the range. So the range is this horizontal displacement x. So x is equal to V naught xt. Remember, the 1/2 at squared is 0. So 51.9 times 10.4 seconds is equal to 539.76, which is equal to 540 meters. Part C says, and D, they want you to find the final velocity. So remember, this is my final velocity, VF, and this has both the horizontal and vertical components. So VFY and VFX. So we know VFX is equal to V naught X because the horizontal velocity is constant, which is 51.9. VFY, how are we going to find that? Well, we know we have little g, we have V naught Y, and we have t. So VFY is equal to V naught Y plus GT. So VFY is equal to 39.1 plus negative 9.8 meters per second squared times 10.4 seconds. So VFY is equal to negative 62.82, which is negative 63 meters per second. You guys couldn't see that. Part D, again, you want to find VF. So VF, we're going to use the Pythagorean theorem, is just equal to negative 63 squared plus 51.9 squared. So VF is equal to 81.6 meters per second. They want to know part E, the angle. So I would find the angle in the triangle and say tan of theta is equal to opposite over adjacent, which is VFX over VFY, which is 51.9 over 63. So theta comes out to be 39.6, but if you look at the answer on your worksheet, it's 50.6 from the horizontal. This angle here is from the vertical, so they're complementary angles. So 50.6 from that. And then the last part, part F, said the maximum height. So to do the maximum height, we're just going to look at this quadrant. So we're going to say that this is V naught Y is 0. And then